Let's understand how a weak map works in JavaScript. But before that, let's see why we might need it in the first place. Let's create the regular map data structure. And if you're wondering what this collapsed function does, it just logs the size and contents of the map with some formatting. This function is not important to our discussion, so let's move on. I'll set a couple of primitive keys and some values into this map, and then invoke the method that will print the contents of the map. Then I create a function within which I add a key of type object and a value of type string to the map. Let's call the function and finally print all the contents of the map. When we run this, we can see the size and contents of the map. Here we can notice a behavior of the map. A function add object key to map has returned, and the object key should have lost its scope outside the function. As we can see here, we get a reference error because that variable is out of scope. But the map still holds the value and key created within the inner function scope. This can lead to memory leaks. Also, a poor design of data hiding, as the current scope shouldn't be able to enumerate something that just went out of scope. This is where WeakMap can be useful. Now let's see how WeakMap does things differently. Our program always has access to two types of memory, namely stack memory and heap memory. When we create an object, the memory address of an object is maintained in the stack, while the object itself is held in the heap. It can be a bit more complex than this in practice, but this simplified view should be enough to discuss our concept. When we create an object named outer object, its memory address is held in the stack, and the object itself will be held in the heap. Invoking a function creates a stack frame, and if I define an object named inner object within the function, the reference to that object will be within the function stack frame. Let's assume we have a weak map named map, and that these two objects are used as the keys in that map. By the way, unlike a regular map, a weak map can only have an object or an object-like type, like a symbol, as its keys. Primitive types cannot be a key of a weak map. So when the function returns, its stack frame is popped, and the reference in the stack to the inner key object will be lost as well. At this point, the key named inner key in the weak map is weakly held, which means the garbage collector can clean it up during its next sweep of the memory. This is how a weak map works and prevents memory leaks. Let's write a demo code. So I'll create a new weak map and set the key value pairs as follows. Then I'll create a function which will set another key value pair in the weak map. Let's invoke the function. Let's rename this to inner key for clarity. It's important to note that we can only set, get, and delete entries in the weak map. We cannot enumerate it or get its size. This is because the operation will yield non-deterministic results due to the garbage collector's activity. So weak map doesn't support size or entry enumerations.